So our first speaker will be Alex Flanagan from TELUS. Thanks.
Yay, okay. Thank you very much. So I was joking with Paul just now. So I work at TELUS Digital. I'm going to talk about that in a sec. We are doing GraphQL. It is going, because as Jess mentioned, we're hiring so many people. We don't actually have the staff to do it right now, so I've pushed it out into Q3, Q4. Bill at the back there has done some great POC work for us. Wave, Bill. Hey, yeah, come work with Bill at TELUS Digital, and we can do some of this stuff. So this is our first slide always. So this is about how we help, GraphQL generally is about how we help our team members do what they want to do more easily so that the team members can help the customers. So I'll talk a little bit too about what Jess was talking about. Who is TELUS Digital? We are the disruptive influence within Big TELUS. We are the internal startup. We're tasked with cannibalizing TELUS from the inside out so our competitors don't do it to us first. I used to work in banking, and I used to be a game developer. And so the enterprise tech adoption cycle is about 5-10 years. And banks are about 8. Mining industry is really, really slow. Telecom's a bit faster. So GraphQL is going to become, assuming uptake and everything, it's going to become an enterprise skill in kind of around 3 years. That's when I'd expect it to start showing up more in job postings, although it is in TELUS Digital job postings now. So why me? So I'm TELUS Digital's principal integration architect. I used to be a technical product owner, but they told me I was doing too much architecture. I was a game developer for a really long time. I started making HTTP APIs in 2007 on Skate 2 for Electronic Arts. That's how all of the leaderboard stuff is done. And I had a kind of a career segue into accounting. So since this is a talk about a business case, I'm going to talk a little bit about business stuff here, like accounting. But first I want to say, kind of who's here? Are we all technical? Who's technical? Kind of hands up. Okay, everyone, good. Who's a manager? So are you guys manatees, like technical managers? Managers who are techies? Yeah, okay. 1 or 2. Okay, so I'll keep this more technical then. So there are really kind of 2 key insights into GraphQL that are key for making the business case. So what a business case is as technologists, we want to sell this to management. And management is always going to say like, oh, yet another protocol, like why do we care? So this is why we care. The TLDR is that we're going to attract more customers with this stuff. So does everyone know what technical debt is? Yeah. Okay, good. I'm going to maybe go quickly through the next kind of little bits here on terminology. Oh, this slide will make more sense to the techies then. Right, so we used to have SQL, which was SQL, 3 syllables, very inefficient, so we called it SQL, which is 2. GraphQL, I've been trying to get GQL going, but it's kind of this like suboptimal compromise. It's like, it's 2 syllables and it's kind of weird to say. GQL is faster to type. Graph is 1 syllable, but it's not really exact. So let's move on to accounting terminology. So I want to introduce, it's not really an introduction, but I think of technical debt as a virtual liability. Again, apologies for the kind of business language, but this is kind of how you can talk about it to management. So by virtual liability, I mean it's not an actual accounting liability. It's all of the like crufty stuff inside your technology, right? So your technical debt service is the incremental cost for a change in addition, like over and above what it costs to actually make the change. So there's some amount of development effort which will make a change. There's some excess amount of development effort which is required because the software is crappy. And so technical debt isn't really a liability. It's not a real debt, but the cost to service it is. You can think of it as an interest payment you're making on poor technical investments. And the only way to pay it down is through engineering time, so it's a very real cost. So this is, as you're building your business case for deploying GraphQL, you really want to be talking about, ideally you're always talking when you're making a business case about capturing revenue. But you can get really, really technical in terms of finance and accounting about cost measures here. So if anyone here knows accounting, you're kind of debiting the technical debt service expense, crediting the technical liability. For finance geeks, what you're doing is you're optimizing the net present value calculation of the stream of kind of tech debt service payments, but I'm just going to skip over that. WACC there means weighted average cost of capital. So it's kind of like over the life of your project, and given how much money actually costs you in the market, and how much engineering time costs you, how much is it actually, how much is your technical debt? You can actually put a dollar figure on it. So back in the agenda, we talked about 2 key insights. So what are they? Insight number 1 comes from asking the question, what is GraphQL really? I mean, it's a piece of software, but what are we trying to do with it? So GraphQL was developed by Facebook, as we all know. This is a terrible reason to adopt it. A much better reason to adopt it is that it's developed by Facebook to address an issue that Facebook got to before other enterprises, because they are scaling faster, and Facebook is an enterprise. So anytime someone says, I'll kind of hammer TELUS a bit here. Anytime someone says, oh, we're doing this because this is one of the 5 titans is doing it this way, that's a terrible, terrible kind of reason for, it's not an engineering reason, it's a marketing reason, right? So why make a technical decision for a marketing, with a marketing justification? So TELUS has a bunch of internal APIs, REST APIs, that always return 200. And the reason they always return 200 is because, well, Facebook's APIs always return 200. And I still haven't seen, I'm sure that it exists somewhere, I still haven't seen the technical argument for why Facebook does that, and it certainly doesn't apply in our use case. So Facebook has bigger problems than most companies. They're coming up on 2 billion users. And quite frankly, they have scale problems that other people just don't. So I want to talk a little bit about enterprise application architecture. This is my simplified diagram. Yeah, the rest is just kind of details, right? So the arrows between these boxes, the boxes themselves, there's a lot of detail that they abstract, but this is fundamentally what you're doing. This is why, COBOL is still a really, really popular grind for old school bank engineers, because it's that old joke, which some of you heard me tell earlier today. It's, you tap the machine with a hammer, and then you send the guy a bill for the business, a bill for $10,000, and they say, whoa, 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 you just hit it with a hammer. Why $10,000? It's $9,999 to know where to hit it and $1 to actually hit it. So what you're doing here, the reason I bring this up is you have this separation of concerns. You have app developers, API developers, back-end developers. You separate them so that they can specialize. If your app developers, and we do run into this in TELUS, if your app developers are also writing APIs, they are good at neither. They end up being passable application developers, passable API developers, but specialization leads to expertise. So let's start building. Let's imagine, so I'm the principal integration architect. I run the API team. So let's take that API lens and look at this. Let's start building some APIs. So we're going to help our business by releasing some software here. So what is GQL? See, it doesn't really roll. Version 1, we release it. Users love it, but there are just a couple of bugs. So we're going to fix those bugs and release version 1.1. And users love it. Users love this API. They're like, you know what? I've standardized. I'm never leaving version 1.1. So immediately you can see you're developing technical debt. You're supporting version 1. You're supporting version 1.1. Now you do a breaking change. You're like, okay, I'm going to have version 2 of my API come out. And oh, there's a major security bug that we have to backport to version 1.1. So now we have version 1.2 and version 2.1. And users love both of these things, but there's just a couple of bugs. We're going to keep fixing them. So you see how this generalizes, right? We're going to start seeing massive, massive, massive technical debt accrue. And you can manage all of this And the way that enterprises typically manage this is that they have versioning policies, they have deprecation policies. They say, okay, I'm going to have an API forum. I'm going to communicate with all of my API users. I'm going to say, you have to upgrade. You know, here's my roadmap for deprecation for 1.1. You're coming up on the 3-month point. I'm removing mutations. I'm just allowing reads now. And you go and you go and you go. And there's a lot of cost, a lot of communication. You have API review boards. And it's just this really, really hard problem. It's actually a classic platform scaling problem. And this is one of the key kind of pieces that we want to address here. So we're trying to build platforms and in enterprise, right? We're trying to give application developers, taking the API view, we're trying to give application developers a platform on which they can build. And we're starting to see that this doesn't scale. As we add features, as we add functionality, we're slowing everything down. We're not speeding up. And we're accumulating technical debt like crazy. And not only that, but, and I actually had, so very, very, like last week, this is a real problem. So I had a user that said, you know what, I really like version 3 of this API. Can you guarantee me that you will support it in perpetuity? And I said, no. Like, just clearly no. A lot of the time you're getting product owners asking this question, and they don't really understand that they have to build this technical debt remediation into their product cycle. So no, you can't do a permanent integration with version 3 of my API. So I come back to it. What is Graph? We've introduced this problem. So application developers now have to know a lot about our versioning policies, a lot about our documentation. They have to pay attention to Slack channels. Just by calling APIs, which are supposed to simplify things, we've increased their technical debt load. I've also pushed the technical debt from my platform out into application code, and this is a real jerk move. And I'm maintaining a bunch of smelly old APIs, version 1 with the security hole, et cetera, and they're just sitting around soaking up operating expenditure. They're costing money to run in the cloud, they're costing support. It's just a bad use of resources. So already you can see this is a kind of it's not intractable, but it's a difficult problem. So as a technologist, I think, well, I don't want to solve this people problem. I am going to solve a technical problem instead. Because, you know, it's more fun. So let's talk about versioning then. So how do we version these things? API calls kind of look like this. If you haven't seen them before, I guess all you guys had. I kind of prepped this talk as though there were going to be more business people here. But so, you know, a RESTful API call roughly looks like that first line. You're getting an entity. And you can version that on the URI. You can version it in the header. And you can version it using a query string if you want. And arguably, you can use all three. You can say, I have a different version of my query kind of syntax, so I'm going to version that. I'm going to say when you pass in a query, I'm going to version the query. When you, the version on the URI is the version for how we are using the URI standard. The version in the header is related to the entity, or it's related to our header patterns. You can kind of use all of them, but I mean, there's this Chris Rock joke I really like. It's you can drive a car with your feet if you want to. It doesn't make it a good idea. You can do all of this. But it just seems like you're not really addressing the underlying issue. So now, instead of 2 key insights, it feels like we have 2 key problems, right? We're scaling through people. There's all of those like review processes you need in order to scale all of those versioning policies. And you're starting a technical holy war over versioning. And people are going to be like, version on the URI, no, version on the header. And we really don't want to be having these arguments. These equally seem very difficult to fix. So now we ask ourselves the question, can't someone else do it? Someone else. So Facebook is that someone else. They ran into these problems a lot before, like a good deal before anyone else. So let's return to first principles and try to address both of these, the scaling problem and the technical holy war problem. So what is GraphQL? I keep asking this question. And it's, as a user, you don't really care about the API. What you want is the data. The API is just a vehicle for the data. So let's kind of pull out our IDE and hack a little bit. Not really. But let's take header versioning. We can do this with any of those kinds of versioning. It's easier with some than others. But let's take header versioning. And let's say, I'm not going to ask for a version. I'm going to ask for the fields that I want. So instead of passing in that X version header, I'm going to pass in X fields. And I'm going to say, give me the name, address, and phone number of this client. And we've solved it. There's no more versioning. We don't have versions in that construct. But what happens if the data fields change? And we see, well, instead of address, we're going to have street number. Instead of phone number, we're going to specify that it's the TELUS home phone package. So still, we haven't actually, it seems as though we haven't introduced versioning. And I assert that, in fact, we haven't. You shouldn't do this, but if you're using this pattern, you can write applications and forget about them. They can retrieve these data repeatedly and not need to be updated. Maybe. They'll always need to be updated. You shouldn't do that. So GQL, what is GQL? So one of the things that you could do is you could change the definition of the schema within a field. So you could say, when I ask for the name, I'm actually going to not return their name. I'm going to return an object with first name and last name fields. Just don't do that. Make a rule that all of your changes are going to be additive and non-breaking. So we're not going to take anything out of the spec, and we're not going to change the schema of anything that we return. We're just going to not care about the version. We're going to specify this X fields thing. And you notice here, the version is now totally independent of the result. So I can call version 55, 54, version 12, and because I'm passing in the username field, I still get back my username. So the version no longer matters. So it seems like we're onto something here with this modified header kind of way of versioning. It's not really versioning, but we're kind of doing a version-like thing with it. But the key, we're coming up on the key insight here. So remember the definition of technical debt. These teams are no longer have an incremental cost of maintenance in addition to the cost of the changes that they're making to their API. They are just consuming data. So I've now pulled that technical debt that I pushed out into my application teams back into the API platform where it belongs. And this, I should say this isn't the actual history of how they developed GraphQL, but this is how I came to understand its value, because I was running through this versioning nightmare, and I realized that this was kind of the thought process that gets you to where GraphQL is. There's a couple of other ways to get there. Like you can, conceptually, if you're posting like a Swagger to an endpoint and then it generates a response and sends it back, that's also very similar to GraphQL. So yeah, they kind of cleaned this up. You know, you're using your post body, you're not using headers. Resolvers are how you can now do, like you can add joins to this by using resolvers. And so what is GraphQL? It's a way to isolate technical debt so that you can scale your application development without running into version management hell. So that's the first key insight for why GraphQL is useful in an enterprise environment. So I actually had this question. And it's a kind of a deceptively stupid question. It's kind of a dumb question, but it's I understand why they ask it. So back in the day when we were rolling out SQL, you had to replace all your databases. So now we're going to have structured queries. We're not going to have these hierarchical databases anymore. So I was talking to a kind of a technically savvy manager type, and they said, well, I mean, if it's a graph query language, are you suggesting that we swap out all of our databases and start using graph databases? So it's actually a fairly elegant question. It demonstrates a degree of understanding that is imperfect, but it's a fairly intelligent question for someone who doesn't understand the technology kind of offhand. So we go back to first principles. What is actually a graph? So GraphQL is kind of a way to query, it's actually hierarchical as well, but it's a way to think about how to ask questions of a graph. And remember that Facebook is mostly solving advertising problems. So they want to have questions of the form, give me all users who are fans of the film Matrix and have recently been married. And graph traversals are how they have chosen to do that. And again, so you guys know, graphs are just nodes and edges. It's a very simple mathematical model. It's kind of a generalized tree. So remember this slide where I said, remember how the rest is just, or the rest within these boxes is just details. So the key insight here, the second key insight, is that what we're actually doing is treating the back end, the enterprise back end, as the graph. So the APIs are not, graph is not now calling, it's not now looking at user records and finding out the things that they've liked and are interested in. All of these circles now represent systems within our very complicated enterprise backend. So all enterprises fundamentally accumulate massive tech debt over time. TELUS, for example, has grown through acquisition. So we bought 17 companies, therefore we have 17 billing systems. So the connections and the interrelations between them are what we're mapping using resolvers. We're actually using graph to ask questions of our own back end. So this is really the second key insight. It's what graph are we querying? We're querying the architecture of the enterprise itself. So yeah, the resolvers actually encapsulate the knowledge of how, for example, those 17 billing systems interrelate. So you can ask for a customer bill, and then the resolver itself knows, okay, I'm going to look in all these different systems, I'm going to compose the answer, I'm going to return it. So this goes back to that separation of concerns. Now you don't have application developers and API developers and back-end developers, and sometimes the application people do a little bit of API work, and sometimes the API people do a little bit of back-end work. Now, this is the structure that I find at TELUS. Now what we're doing is we have a team that writes GraphQL resolvers. So they do these deep dives into application architecture at the enterprise, in the enterprise ecosystem. They say, these 17 billing systems fit together this way. They do all of the analysis, all of the business analysis necessary to figure that out. They write one resolver to capture it, one ring to rule them all, and then it's just transparent from then on. So you take not just the business logic, but the business structure, and you encapsulate it. You make it real in code, and then you encapsulate it. So here are two key insights. GraphQL helps us scale application development by isolating technical debt, and the technical debt that we are isolating is the knowledge of the enterprise backend itself. So let's cancel terms and simplify a little bit. GraphQL allows organizations to scale application development, but it's actually customer experience, because I don't know about Rogers and Bell, but TELUS cares about its customers. So our customer experience is scaled independently of the complexity inherent in our back end. So here is the business case for GraphQL. GraphQL helps us win more customers by simplifying our software. Now, when you're talking to the business side and you're selling GraphQL, this is a very easy sentence to say. And it will sound, it's intentionally designed to sound like a talking point. It's giving them ammunition to go use in meetings with their own superiors. But this is the intellectual justification underlying this talking point. So it's not just hollow business politics. Like everyone wants to win more customers and simplify software, sure. But this is actually how it works. This is how this sentence is true. Alrighty. Any questions? Oh, I've explained it perfectly. Amazing, yes.
How has your GraphQL implementation been compared to what?
Yeah, compared to what?
Compared to what what the systems have been previously.
So I'll talk a little bit about one thing we've done. So as I said, I pushed out most GraphQL development into Q3, Q4 this year. We're ahead of the adoption curve, but we're still way slower than startups, kind of naturally. These are all real problems I'm talking about, right? So API development in enterprise is inherently a communication problem and a people problem more than a technical problem. Sure. It's not hard to like hammer out REST APIs. It's hard to orchestrate 120 developers to always make perfect REST APIs. And so and then the meetings that they have to have with the back-end teams are quite difficult. Sure. But one project that we did run successfully, thank you, Bill, is wrapping Contentful, which is a CMS. We've actually talked about it in this space before. Some of you might have been there. Contentful ships with a plugin which provides a GraphQL interface, but we wanted to, we're always concerned about vendor lock-in, right? We don't want to standardize on a startup's platform. So we built our own abstraction layer around Contentful using GraphQL. And so it's hard to say without running a bunch of projects because Bill is a great developer. And so, you get different quality developers, ask them to do different amounts of work, you end up with different results. But Bill flew through it. It was pretty fast. I would say it was arguably faster than doing it RESTfully, but it is quite arguable. Yeah. Yeah. Yes?
So it sounds like you can never deprecate a node in your graph.
So the question is, it sounds like you can never deprecate a node in your graph. Let me talk about that for a sec. So, sort of. Except, as long as the contract that you return is always the same. So back to this stuff, right? So imagine for version 54, what I'm doing is I'm deprecating a node in my graph. But what I've done is I've replaced that node with another system, or I've replaced a set of 3 nodes with 1 node, which are functionally equivalent. You just want functional equivalence, and then making sure that the interface contract doesn't change. So you can deprecate nodes. This is the build a facade and strangle pattern. You cover it with an API surface, and then what's happening under the API surface is invisible to the application developers as long as you maintain strong interface contracts. Yeah. Yes?
Sorry. So basically, then the resolver would be the one who's handling the deprecation, or?
Yes. So the question is, so the resolver handles the node deprecation. Yeah. So you don't eliminate the job of having an API. That API team becomes more concerned with making really good resolvers. So in order to fully deprecate a node, yes, there will be implementation effort at the resolver level. But the idea is and there would be anyway at the REST API level too. But really what this is addressing isn't the API to backend connection. It's just a subtle, it's like a chiropractic adjustment, just a little bit of an adjustment to make it so that your front end can scale. It's really about front end scaling rather than back end. Yes? Yeah.
So
I somehow understand the need of you creating an API in front of the backend. In the case that you're basically just building on BFF.
Yeah.
In the specific case of TELUS is because you have SPF, the backend.
Someone knows our backend architecture. Okay.
But why don't you consider the backend should also be separate GraphQL service, and then you have a BFF that integrates with other GraphQL service?
Yeah. So to summarize that question, it's kind of why don't we do federated graph? Like why don't we push the graph back into the down into the back end? You could. It's so I mean, remember like Conway's law is not a joke. It just sounds like a joke. It's the software you build necessarily reflects the organizational chart of the organization building it, right? So we could easily build it that way. By which I mean we could push GraphQL resolvers into our deep backend. We do not control the deep backend, so that's why we don't do it. This is our point of control, so this is the knob that we can turn. Yes?
What tool are you using to implement GraphQL on the server and on the client, and why?
Yeah, so actually I feel like I should get Bill up here to surprise him with question answering about the technical stuff, but I won't. So we started off, we actually did, mid last year, we did a GraphQL POC, and that was all, we didn't use a tool. I mean, aside from the normal graph libraries, we actually wrote our own custom graph server with the Facebook libraries. But the reason I had the team do that is I don't like building technology, I don't like using technology that we don't understand at a fundamental level. So once that POC was done, we did, Bill's graph work, I think, was using Apollo. We use that for the server there. And client side, it's just like, our front end, I think, uses Redux or something like that. And so it's just JavaScript consuming it. Yeah. Yes?
So now that you have upper management buy-in and the research underway, what are some, I guess, pain points are you seeing, or is there any general ones? And then the second part to that is, what's your technical debt for using that as well?
Yeah, great. So the first question is, now that we have upper management buy-in, what are our pain points? And unfortunately, we don't have upper management buy-in yet. Partially, I'm doing this deck to work out my own argument for why I'm investing more in GraphQL. But the pain points, so yeah, the technical debt inherent in GraphQL is in the resolvers. I'm imagining, I haven't anticipated yet, I don't have a plan for this, but I'm imagining that we're building on sand, right? So that back end isn't static, it changes slowly, but it does change in time. We actually had a funny kind of, one of my developers, one of my tech lead kind of people that I work with, asked me a funny question on Monday. They asked our back-end guys to schedule uptime. And I said, well, what do you mean? And he said, well, when they went on break for Christmas, it was really easy to develop because they weren't touching the servers. So everything just stayed stable. So we could build a bunch. But now that they're back, you know, they're starting to release features more and everything's crashing a lot more often. So can they schedule time where they're not doing uptime? I said, well, I mean, that's not the answer to that. Thank you for asking that question. I mean, you know, we should have mocks and we should have like, you know, high availability deployments and things like that. But so specifically in the TELUS use case, I'm seeing the graph resolvers are going to have a shoddy connection to the downstream because the downstream is going to be itself wonky. But part of the great thing here is that I really want to emphasize that point that you're encapsulating back-end knowledge within the resolvers. So your technical debt becomes itself encapsulated within the resolvers. So when those back-end systems change or when they go up or down, you can invest in the resolvers in order to figure out, okay, well, I'm going to build GraphQL. Also, it's kind of interesting. It works a little bit like a gateway as well. So you can say, I'm going to build a circuit breaker into the resolver. I don't know if that's a good pattern yet, and we're still looking at stuff. But you can start saying, well, if this back-end system is failing, I'm going to return a mock response for reads or a cached response for reads or something like that. For writes, We haven't done writes yet. Yeah, I guess that's all I can say technically. We haven't done writes yet, so I don't know what that is going to look like. I'd imagine it's similar. The back end is going to be a little bit flaky, so it's going to be tricky to write a perfect resolver that you never have to touch again.
Every time I heard there's going to be one place where your technical debt is going to be.
Okay, the question is, I've heard this before. We're going to aggregate all our technical debt. Yeah, cool story. Maybe, I don't know. Like, does anyone watch the new Star Trek? I just watched the latest episode last night, and they're like, I refuse to believe in the no-win scenario. Kobayashi Maru. Yeah, okay. No techies, no Trekkies in the tech audience. None? Give me some love. Okay, okay. Yes?
Have you thought about how you're going to transition from a RESTful API to GraphQL?
Yes. So the question is, have we thought about how to transition from a RESTful to a Graph API? Initially, this is a larger question about our roadmap for the platform, so I'm going to hand wave through a bunch of it. But what we're going to do is stand up Graph. Initially, Graph is going to be calling REST. And this is terrible because as you add up layers, I mean, you're getting at least 50 milliseconds on every layer in your stack. And we want to keep these API responses like lickety split. But we're going to initially have feature parity by using Graph to call REST, and then do exactly what I said, replace the resolver, drain the traffic to the REST API goes away. I imagine it's a little bit of a no-win scenario, and enterprise being what it is. I imagine that what's going to happen is that REST will live as long as SOAP has lived, right? So it's just, we're just going to end up with layers. And Graph, the great thing about TELUS Digital is that we are able to torpedo technical debt. We can actually box off systems and chuck them out as long as we have functional parity, but that's just tricky. But it's the same pattern you build on top. Make sure you're functionally equivalent, drain, strangle. Oh, you already asked one sec. We've got someone new.
Okay. Can you give us an idea of how many requests you're dealing with?
Oh,
Scaling problems you're coming to?
how many requests we're dealing with scaling problems. It's actually, it's not a traffic scaling thing. It's a development team scaling thing. So if we wanted to build 5 more applications or 20 more applications, that's the kind of scaling that I'm talking about. So how do we go from having market segments of several thousand users to, or you know, several million users to market segments of several thousand users? And you do it by targeting apps really fine-grained, but that means that you need to be able to scale your application development teams. In terms of traffic, I don't know if I'm allowed to say, but we deal with something like 30 million requests a day. It's on that order. Or no, a month. A month? A million a day? Something like that, yeah.
In consumer website, 14 million requests per day.
Oh, okay, consumer website, 14 million a day. Yeah.
That's going through GraphQL?
No, not going through GraphQL. We're just starting to move our marketing pages. So a marketing page is, say you're in Saskatchewan and we've just bought the local telco and we're going to give you a some kind of discount if you, or they've closed the local telco, and we're going to give you a discount to move to us instead of Rogers. We want to get those kind of marketing pages out really quickly, and that's built within those are built with an internal product, and we're transitioning that product to GraphQL reads only, but it's nowhere close to millions, not yet. Reza.
Are there any scenarios that you don't recommend GraphQL?
Oh, scenarios I don't recommend GraphQL. No, it is a golden hammer and should be used to hammer all nails. I think it's really about, it really fits this kind of stuff here, the stuff OKGrow does. Like if you're doing a JavaScript ecosystem based on React in the front end, it's a really good fit. I mean, kind of by design, right? Because it's a Facebook product. I actually don't know if we should be pushing it into the deep backend. I think Yeah, I don't, there's an idea too of like, should you have one big graph instance or several, like a sharded kind of like mass deployment like that? And I find that the deep backend stuff, like this is, I used to call this around the floor, do we do Death Star, do we do TIE Fighter? And I think we kind of settled on Death Star. We want one massive instance that's serving everything, and then like it's a logical instance, right? So like within it, it can have high availability and things like that. But I think as we talk about pushing graph into the deep backend, that's maybe kind of a bridge too far. It's I don't know if having a bunch of them within TELUS leads to insanity of resolvers for federation, all of that stuff. Yes.
I have a quick question about versioning.
Yeah.
Kind of based off the slide you have there.
Oh yeah.
So if you have an interface that's locked and there's kind of a contract around it, why bother having versioning at all? Why not just have the current API version at all times and just drop the number?
Yeah. So the question is, why version if you have a stable interface contract? I totally agree. You wouldn't. The interface contract changes all the time, though. It's we're always trying to launch new features, and it's a good example right now is we're doing some kind of mesh networking in the home, and this we're exposing a bunch of new features for letting you use the TELUS app to control your home router, and I don't know. There's some kind of, you're causing me to flash back to my business day, man. Like my work day. No. There's some kind of business case around surfacing a new feature. So a good argument to business isn't, oh, I'm sorry, the interface contract has been set in stone, lo these 5 years. I will not release any new features. They'll immediately fire you and hire someone who will. So it's just not effective career strategy. Yes. Anyone else? In the back? Yes. Once more.
Last question.
Oh, okay. I'm just going to go to someone else. You had a question in the back corner? Red shirt? No? Okay. All right, one more.
Sure. It was kind of based off of this gentleman's question.
Yeah.
About switching over and in general versioning again. But why not just say to a lot of the application developers, by X date, you have to switch over to new GraphQL API because it is going to make your application better.
Yeah, I mean, it's carrot and stick, right? So the question is, why don't we just say, by X date, we're going to switch over? We do that all the time. It's really about minimizing the amount of just kind of thrash in meetings and communication and minutes and all of that stuff. It's just about minimizing cost. Yeah.
There's also the problem on mobile. So like if the consumer of the APIs are mobile applications, you'll have a hard time pushing these updates.
Yeah, so the point made in the audience was that for mobile applications, it's very difficult to push updates and have all of the users download the thing. We had this with a certificate rotation issue. You kind of have to talk to Google and Apple, the gatekeepers of the walled garden, and say, hey, we want everyone to update their app, and you have to have a very good reason of forcing a remote update. Oh, we've locked it. Okay. Thank you, everyone.
Okay. I'm going to hand it over to Evgeny.
Thanks. Hi, everyone. All right. I have 70 slides, but I'm going to go very quickly. I know we're all very busy, and we don't have a lot of time. So, okay, my name is Evgeny Lee. You can find me at Exaspark, GitHub, Twitter. A little bit of background, no emojis for some reason. So, I was born in Uzbekistan. This is a country near Turkmenistan, Kazakhstan, and all other stans. After that, I moved to Russia, lived there, graduated from the university, moved to Cyprus, a sunny island in the middle of the sea, number 4, and now I'm here. This date, it is something special about this date. I'll tell you a secret. This is a due date of my wife. She's pregnant, so anytime, if I receive a call, I'm gonna leave this conference. Sorry, guys, just in advance. Okay, I work at... I work at a company called Universe. This is a ticketing platform. We sell a lot of tickets for a lot of organizations. You can find the logo on the top. Does anyone know the last logo? What does it mean? What's the event? Yeah, that's GraphQL Summit. So we hosted it in 2017. And I have, to keep your attention, we have a few presents. We have a bunch of stickers. And also, I would ask our CTO, Josh, to evaluate the questions at the end. And for the best question, we're going to give this t-shirt. Okay. This is what you do when you have a lot of stickers. Okay, it will be my personal journey, so don't try to generalize about it for the whole company. And my journey started in 2016. So I built a small application which I'm still using. The idea was to filter my Twitter timeline because I don't want to scroll all my day. And I wrote a small algorithm to range the best tweets. So it shows me only 20 best tweets. And the algorithm works the way so it shows me the tweets from maximum number of people. And I built this application with GraphQL. I used a lot of other buzzwords at that time, but the general idea was that it was that simple application. It didn't require database access. Everything was stored in your, for example, cookie. You can still go and visit this website and check that out. And with this cookie, it could make requests to Twitter. Yeah, that was my first experience with GraphQL. We also have a lot of experiments internally at Universe. We do monthly hack days when we are trying different technologies, including GraphQL. And we also hire, by the way, sorry, I mentioned it. We don't have a dedicated person for it, but if you know Kubernetes, Ruby, Rails, Erlang, or I don't know, Ember, React with Colas. And during my first hack day, it was an interesting story. I literally hacked our website. So I found an active XSS. I loaded my JS code, which defaced the website. So it showed the login form. And of course, from login form, the requests were submitted to my server where I could see all passwords. So this is a nice opportunity to work on something interesting. Another story, this is a true sad story. So I worked previously before Universe at one of the companies in Cyprus, and the idea was to try GraphQL. So I worked in my colleagues were really smart people. They were like rock stars in Ruby community. And that didn't actually work. So we tried to cover all these terms at once, but that was too much. Yeah, the main idea is that the community wasn't really ready at that point, I would say. We couldn't find any best practices, for example, how to test GraphQL with Ruby. We couldn't, and overall, all engineering teams were overloaded by this number of abstractions and terms with GraphQL. So we failed to adopt it. But recently, in July 2017, at Universe, we decided to give it a try. And this time, to, of course, use Agile. Maybe some of you guys know this video. It is a short video, but generally, the idea is the way we work. We basically build the airplane while we're flying at the airplane. This is an interesting video. Yeah, that's our goal, yeah, to build a product while it is not perfect and to continue working on it. I love this job. Okay, the question is why? Why did we try to bother us with GraphQL? And Josh, who is also sitting here, he wrote an article about why we are betting to GraphQL. And it was featured in GraphQL Weekly. You can guys subscribe to this weekly email newsletter. But in short, there were like 4 or 5 reasons. One of them is strong client contract. It means that the way, okay, let me ask you a question. How many of you know what GraphQL is? Basics. Okay, most of the people, like let's say 90%. How many tried GraphQL? I would say like 45%. Who uses it on production? Okay, maybe 30%. Yeah, nice. So in general, yeah, GraphQL is a specification from developed by Facebook, and the idea is that server describes which data it has, and the description includes types as well, and clients can specify what data they need. So server doesn't have any opinion which data to return. It is up to the client what to return, and this is why GraphQL is so powerful. And one of the nice feature on this slide, this is JS, and we use Flow. Flow is like type annotation for JavaScript. We use it in some projects. The nice idea that on the client side, we can validate all the types depending on the schema specification provided by backend. So in this case, we can see the error message or suggestion. Probably hosted field on the profile can be null, so your code will fail. Make sure that it exists. So it is really powerful way to integrate client with server without actually deploying code for client. So we can validate everything, all queries, before releasing them. Another idea for us was to create a new language for all API consumers. Because, to be honest, we are a startup, and the language itself, which we are using currently, doesn't necessarily represent our current state where we are at currently. Because we are moving so quickly, and some of the entities could be duplicated, doesn't have any meaning or something like that. And for us, it was a nice idea to isolate and rename things and start using some useful language for our API consumers who would like to integrate with us, and even internally. So we love domain-driven development. Another reason why we are betting on GraphQL is GraphQL specification. So you don't have to worry about, should I nest entities on the top level in the response or not? How should I return an error message or something like that? Everything is specified in the specification, and you don't have to worry about it. And another thing that GraphQL gives this flexibility, when you have performance issues, you can isolate them on each field level. So, and another reason why we are betting on GraphQL is documentation. By specifying all the description on server side, we can generate it really easily. There are tons of tools. For example, GraphQL. GraphQL is an IDE for querying GraphQL. So basically, we can specify which fields we would like to query on the left side. On the top, on the right side, we have all the documentation with descriptions, which types our server supports, and as you can see, our response matches the request one-to-one. So we started with GraphQL alpha version, and the nice part that we decided to try moving like with small iterations, and the first step was to release something for public data, so we don't have to worry about authorization, permissions, and all other things. So it was only read-only schema. And as you guys heard this joke, I have it. One of the hardest problems in computer science is naming. And naming is the way how you communicate to the customer and how your customers communicate with you as well. And we're still in the progress, but our RESTful API was very bad. I mean, customers were speaking one language. API was representing the state of our internal state, and for customers it was really hard to understand what does it mean, why you guys naming some things which doesn't make sense in outside world. So yeah, with GraphQL we could create a new abstract layer, the API, where customers could consume our API with the nice language. And the second problem is caching, the hardest problem in computer science. And to be honest, we don't solve this problem yet. And there are a lot of reasons, and one of the reasons it is very complicated to do with GraphQL. And our current endpoint works fast enough for us, so we could process thousands of requests per minute. And yeah, why we are deferring this decision? Because smart people say that, and I would agree that the longer you defer the decision, it is, of course, it is all depends, but the more information you have, the better your decision will be. And one of the solutions how to solve the caching problem is Apollo Cache Control. So in short, Apollo guys are working on these extensions. As you can see, data, errors, and extensions. These are things which are allowed in the specification. And people from Apollo would like to add some more information, so your server can say that, for example, this field will gonna expire in 30 seconds. And this number, 30 seconds, for example, will be respected both on server side and client side. Another thing I'm gonna mention is pagination, how to do that with GraphQL. And there is a great blog post. You can find all the links. I'm going to share the presentation URL at the end. But in general, for example, Facebook relay is very opinionated. What should you do? And don't blindly follow all these trends, I would say, because Facebook has their own needs. For example, Facebook is a real-time timeline. In our case, we don't have a lot of real-time things. Facebook is an endless timeline. We don't have endless timelines in our UI. So we decided to skip all these things which relay is opinionated about, and we went with just regular pagination. And in general, I'm gonna cover a lot of topics. You could find useful links at the bottom, but I'm not going to go very deep in each topic. Another must-have thing is authorization, right? In the Ruby community, there is a gem GraphQL Pro. So if you pay $900 per year, you'll be able to use it. But we decided to build our own gem. So we built our own library. It was featured in Ruby Weekly, and it works really well for us. So this is a code example with Ruby. Something went wrong with layout. In general, our gem guard allows you to add just this line somewhere, but it appears on the bottom, and where you can specify the logic how you would authorize each field. And this is, I think, very common pattern. There are some JS libraries which support the same. The nice part that your authorization logic can be extracted somewhere outside of your schema definition, and you can do whatever you want there. So next, after that, in August 2017, we started working on releasing to our GraphQL endpoint. And we added a lot of stuff. Yeah, we added a lot of types. We started playing with interfaces, enums, where you can specify the whole set of available values. We started playing with connections to return lists of items and some validations, so you can validate the max depth. So for example, if your user comes and generates the very heavy query, we can, before executing the query, we can just parse it. And if, let's say, the query has more than, let's say, 10 nested fields, we're going to say, okay, no, we are not going to execute it. And we added such thing as viewer is a common pattern to return current user. And the nice part that we started getting contributions within our team. We have like autonomous teams within our small company, but even like junior developers, for them, it was much easier to understand GraphQL instead of learning like Rails stack, routes, controllers, serializers, and all other things. And it is, yeah, still the trend in our company. It is much easier to contribute to our GraphQL. Another thing I wanted to mention is how do people like solve performance issues? And there is a technique called batching. First, Facebook introduced it in a Haskell library called Haxel. After that, they created a data loader. Probably some of you guys heard about it. This is another library which is very popular in JS community. And on top of that, I decided to create another library called batch loader for Ruby developers. There is also a library by Shopify, but it is not ideal. It uses, for example, such things as promises, but in Ruby world, it doesn't make sense to use promises unless you are using asynchronous, like reactor or something. So in general, yeah, you can find links about how does it work and what the technique is. But it is very popular. People from GitLab started using it for Git calls. You can use the same technique for RESTful APIs as we do for GraphQL. You can optimize your performance for HTTP requests, database requests, file requests, and all other I/O requests. And the way it works, for example, this is a DSL from Ruby, and let's say we have a list of posts, and for each post we are asking for user. It means that we're gonna go through each post and make a database query to load the user for this post. So it is n+1 query. Here comes something. Okay, I'm gonna skip these slides. Sorry about that. It doesn't work in PowerPoint. After that, we finally started shipping some of the UI pages. In particular, we started using Apollo client and React, and we created this widget where our hosts can embed the ticket information from our platform to their website. And it is all powered by GraphQL. So we started slowly releasing more and more things. For example, this calendar, fully powered by GraphQL as well. Then we started thinking how to handle errors, and we decided to create a new library for that because, to be honest, yeah, Ruby community is not that fast-moving community. in terms of GraphQL compared to JavaScript. And there are a lot of opportunities to improve the tooling. And finally, we started getting some beta testers. For example, Apollo, people from Apollo introduced the schema stitching. It is the way when, for example, with our API, they could combine two different GraphQL schemas into one. So some of the fields could be a bridge between these two schemas. In this case, for example, they could ask for event, get the location from our system, and then stitch it to another schema to get the forecast, for example, and weather information from another schema. This is an interesting technique. Also to mention, yeah, we had also the OK Growth training in the office full day. So it is really great in terms of all people in our team could learn GraphQL because not all of them worked with GraphQL at that point. And I personally learned a lot of things about JavaScript as well, and trendy things. And yeah, check that out. And after that, we started releasing more and more things with GraphQL. It was our first fully powered GraphQL-based page within our website. Just to mention how we deal with on the client side, we use Ember, we use React with Redux and Saga in some projects, Nuclear, and it is mainly for RESTful APIs. And we also use, for some components, we use Apollo client. And we ended up using both of these things for managing state on the client side. However, there are some ideas when GraphQL can be only interfaced to all other states. So for example, with Apollo, it is possible to manage the state for RESTful APIs to send a request when you are masking your mutation. So you are communicating through GraphQL to RESTful API endpoint. But I'm not sure that we're going to go with this path. And another thing, yeah, we started doing a lot of more experiments. A lot of more. For those who are familiar, this is Elixir. This is a programming language based on Erlang. It is functional language, similar, but syntax looks like Ruby. And Absinthe is a library for GraphQL. One of the idea was to somehow slowly maybe migrate the GraphQL endpoint, and there were a lot of interesting experiments. I'm gonna go to the next slide. So yeah, another thing to mention, we of course started measuring our performance, and for these there is a tool called Apollo Engine, which is basically a free tool to use under certain number of requests per month. And it is a very nice tool because it currently can show you the error rates. You can see the performance per field. It has a lot of data. The problem was that there were no support for Ruby. So if you know this joke, we basically built our own library to support the engine. If you are using Ruby, you can check this repo where we added the support. The way it works, we are running a Go proxy, which is provided from Apollo, and it sends the like telemetry data to Apollo Engine. So we deprecated with this gem, we deprecated the official gem from Apollo. And finally, we started playing with mutations. This is our first page. This is with mutation. This is page for creating an event. It is mobile friendly, very optimized. So Yeah, so we have some mutations as well. And the nice article to check is what are the best practices for designing GraphQL mutations. Here's the link, check that out. And so what's next for us? There are a lot of things to explore still. For example, we could upgrade our clients who are still using the first version, maybe solve the caching problem if necessary, add more mutations, maybe think about persistent queries. This is when clients, for example, during build time, they can send the query to the server to register it. And after that, they can, instead of sending tons of kilobytes or bytes through HTTP, they can send the ID of this request. And it can save a lot of data, especially on mobile devices. Another thing is AWS AppSync. I'm gonna show you what does it mean in subscriptions and a lot of more. So with Apollo client, it is possible to manually manage the state of the application. So it is potentially possible to get rid of Redux, Flux, and all other things. So we could manually have an access if necessary to change the cache values. Another nice thing, if you're using React Apollo, there is a beta release 2.1 where they finally created this query component instead of using high order components. And I know that internally a lot of experienced JavaScript developers were complaining about it. Yeah, AWS AppSync, this is if you are using cloud. It is also an interesting thing where you can describe your schema, and after that, everything can be executed on the AWS stack. You can use Lambda, serverless, and all other things. And they also provide some client solution for working offline and all these things based on Apollo client as well. So it is very interesting. Another thing I wanted to mention is GraphQL subscriptions. We don't use them yet, but definitely check this talk. It was by the developer at Facebook, and the idea was how to gradually migrate and start using subscriptions. The idea was to add something on top of your existing GraphQL server. So without any changes on your existing GraphQL server, you can start supporting subscriptions just by adding something on top, which can manage the queues, and can manage the state. It is really interesting idea. So takeaways, yeah, solve all these problems one by one, and there are a lot of problems to solve in GraphQL, such as I mentioned, error handling, performance optimizations, for example, authorization, and so on. And here's the link. If you would like to download this presentation, you can find it there. Thank you. Do you have any questions? I see your guys overloaded, right? Yes?
So how did you solve the problem with duplication between your database models and your types in Rubyland?
Yeah, so we basically manually described our GraphQL schema in Ruby. So we added an extra layer. And the reason is, it is possible to generate from database, for example, the schema on server side, but we didn't do that because, as I mentioned, we wanted to create a new layer, a new language, so which makes sense for our customers. That is why we did it manually.
Is it like open source or something?
No, we just use the official Ruby GraphQL library where you can start describing your schema. It is very similar to JavaScript. You can specify, for example, which field you have. This is like a node in the graph, how they connect two nodes, how two nodes connect to each other, and you can specify a resolver where your logic lives in. So you can, in the resolver, you can make a database query, you can make a query to external servers, and so on. Thank you. Yeah?
Can you maybe
Yeah, about our mistakes. So one of the mistakes which I did in previous company that as I mentioned, we started doing a lot of things at once, and we tried within a short period of time ship something which will be useful on prod. And it is really hard to achieve, I would say, if you're a startup especially. This was one of the problem, yeah. So try to move with smaller steps. Don't over-optimize in advance. Yeah, if possible. Yes?
Do you see your backend moving to JavaScript? And why or why not?
Yeah, that's a good question. I would say that JavaScript backend is something like really hot right now. I mean, there are a lot of tools which other languages don't have, and this is because Facebook supports these libraries and so on. But I think that we won't be able to migrate to JavaScript backend because we have a lot of logic written in Ruby already, and it will be really hard to just stop writing in Ruby and port it somehow to JavaScript.
Does GraphQL support any sort of aggregation?
What do you mean, aggregations?
For example, calculated fields. When you're sending a request, you have a calculated field to like give me a count of something or the average of something or a sum of something. Does it have any sort of thing similar to what the databases have?
No, you have to define it by yourself. So GraphQL specification is just the language, how you can describe your server. And yeah, if you would like to add some aggregations, you have to explicitly define a type which says, okay, this is sum of some values and return integer, for example. Yes?
Silly question, but your mutations, how do you deal with transactions? For example, two mutations and one of them fails, how do you handle the mistake?
Yeah, in our case, if the question is how we deal with failed mutations, in our case, if the mutation fails, we roll back everything. So it is almost on database level. So it doesn't, any like partially applied changes doesn't affect other mutations. And if the error happened, the GraphQL in the errors key in the response returns which exactly like field failed, why it failed, if server provides some more information. And yeah, we log these errors and it is easy to see them in the monitoring tools such as Engine. Yes?
So do you have any, like, were you able to make an example of like a graceful degradation app where like, I saw you had that example where you go to the weather app to fetch the temperature.
Mm-hmm.
Like what happens if it's unavailable? Did you have a chance to see like return a mock response like Alex mentioned?
Yeah, there are a few patterns how to deal with errors with GraphQL. One of the pattern is fail the whole request, so your client won't receive anything. But another way is to return only those fields which were valid at this point. So, for example, we usually use this pattern. So it means that if one of the field is failing, you still will get some data back. But at the same time, you will have in errors, you will have that this field somewhere nested was errored. So it is partially returned data. Yes?
Are you doing any testing for automated testing to test your GraphQL queries?
Yeah, so from testing perspective, we use TDD. So we basically on the lowest level, we are trying to test resolvers. It is much easier because you're not testing the whole HTTP transport. You don't test authorization at that time. You're just testing your code. At the same time, we just using some other tests. For example, we have a few which covers the whole request. We also have UI tests, which is basically a smoke test which go through our UI, click on the links, on the elements in HTML, and make sure that the correct state on the DOM appeared. And we also do sometimes manual performance testing. So for example, we had an on sale where we had a lot of requests. What we did, we manually tested our queries, which we knew we are going to use because the hosts were using our client code. So they were using our widgets. So we could easily test the performance of our queries. Any other questions? All right. Thank you very much.